We're starting a new lesson today. On 9.5, we're talking about special products. So before we do that, I want you to go ahead and pause the video right now and go ahead and use the FOIL method on all four of these binomials. Go ahead and solve them using the FOIL method. So go ahead and pause the video and we'll go over the answers. So the first one, you should have x squared plus 2xy plus y squared, and then x squared minus y squared. The third one should be a squared minus 25, and then a squared minus 10a plus 25. Our lesson today is we're going to be looking at these different types of binomials here, and there are different patterns. So if we have binomials when it's the sum here, or if a sum and difference, or the difference of both of those, we have different patterns that we can draw from them. So let's use the FOIL method one more time here. 2x times 2x, and then so on and so forth. So go ahead and pause the video here, solve this one using the FOIL method, and then we're going to go over the answer. So the answer is 4x squared minus 9a squared. Again, FOIL method is multiply your first terms, 2x times 2x, that's 4x squared. Multiply your outside terms, 2x and positive 3a, and then your inside terms, 3a, negative 3a, and 2x, and then your last terms, negative 3a and 3a. So notice here, we've got a negative times a positive. We're going to talk about this a little bit more, but that's a negative 6x squared and a positive 6a, or excuse me, not negative 6a squared. We've got a negative 6ax and a positive 6ax. So, negative 6ax and positive 6ax, those are opposite terms. Remember, the sum of opposite terms will always give you 0. So that's why we don't have an ax term in our final answer over here. So here we go. Let's talk about the first one. The first one is going to be the square of a sum. The square of a sum. So notice here, here's our example. We've got a plus b, a sum, and it's being squared. Your answer will be as follows. Whatever the a value is, it'll be squared. Whatever a and b are, if you multiply those together, so that says a times b, multiply this number times b, and then multiply it by 2, that's going to be your middle term. And then your last one is going to be b squared, whatever this one is. We're going to look at some examples. But anyways, this is what you need to memorize. And again, these are what's the word? Just quicker ways to solve these if you can see patterns like this. So go ahead and write this down. Probably until you get the hang of it, you'll need, we're going to study 3 of them in this lesson. What you'll probably do is you'll just have to look back at all 3 of these to see what the pattern is. So let's do an example. X plus 2 squared. So again, we have the sum of a square. So my final answer, again, if you go back to your previous slide, it's going to be whatever a is squared. Remember, this is represented as a, and this number right here is represented as your b. So again, that's what your formula is. Plus, that's important, it needs to be plus 2ab plus b squared. So let's figure it out. So the first thing is, all right, x is represented as my a, so my first term is going to be x squared. Or, again, we're talking about, okay, x is represented as your a right here. So my final answer is going to be x squared plus 2 times a times b. Well, what was a? A is x. b is positive 2, so a times b times 2 plus, what's your b value? Your b value is a positive 2, so we're going to square that, 2 squared. And then simplify it, your final answer is x squared plus 2 times 2 is 4, 4x plus 4. This is your final trinomial, x squared plus 4x plus 4. Let's do another one. Again, we have a sum right here, 3x plus 4 inside here, and it's being squared, the same thing being multiplied by itself. So this whole 3x right here is going to represent my a term, and positive 4 is going to represent my b term. Here we go. We need to square the first term. So the whole first term, 3x, is going to be squared plus 2 times, well, what is a? A is 3x, so 3x times your b, which is 4, so 3x times 4 times that 2, again, this is like your formula up here, plus 4, or b, squared. Let's simplify. What is 3x squared? Well, that's 3x times 3x. 3 times 3 is 9. X times x is x squared. Don't forget that square right there. 2 times 3 times 4, that's 24. And then we've got an x right there, so that's 24x. Plus 4 squared is 16. This is your final trinomial. Again, you're going to need to write this on your notes. You're going to need to memorize this if you're going to use this little, this hint, it'll save you some time anyways. All right, let's talk about another one. What if we have the square of a difference? So instead of a plus b squared, it's a minus b squared. So let's talk about this. Well, again, a squared is going to be the same. That's not going to change anything. This is going to change though. We're going to be subtracting 2 times a times b. So we're not changing that. And then plus b squared. So what was the only thing that changed here? Remember, the sum, the square of a sum was a squared plus 2ab plus b squared. The only thing that changed between these two squares is that subtraction sign right there. That is the only thing that changed. Okay, so that'll help you to memorize this one a little bit easier, a little bit more. So the difference, the square of a difference, y minus 3 squared. So again, we're going to be squaring that first term. Your y is represented as your a, and then b here is your 3. All right, let's see here. So we've got y squared minus 2 times your a times your b, which is 3, plus 3 squared, whatever your y is 3, and we're going to square that. Simplify that down, y squared minus 6y plus 9. Let's do another one. Got the square of a difference, so this is your a value, and this is your b value. Again, this subtraction sign right here, don't get too confused there. The subtraction sign there is going to tell you which method you're going to be using. Now, if we were using the FOIL system, that subtraction sign, that would be very important. That would be going with the negative. That would be negative 5y or negative 3, and you would have to use that in the FOIL system. But the negative sign here, when we're doing our faster method, that doesn't take as much time, that's just going to tell us, oh, okay, we're doing the difference of squares, okay? All right, or get my words tangled up. The square of a difference. Here we go. So we're going to square my a, so square 2x minus 2 times my a value times my b value plus my b value squared. Let's simplify. 2x squared is 4x squared minus 2 times 2 times 5, that's 20. X times y is xy. 5y squared, gotta square both of these things, so 5 squared is 25, and y squared is y squared. So here is my final polynomial, my trinomial. All right, and then the last one, if we have two binomial expressions, so two binomials, one is the sum of two terms, and the other one is the difference. We call those conjugates. Here, let's take an example. A plus b times a minus b. So we have the sum and we have the difference. We've got two binomials and they're the exact same, but they're the different signs. Here is what we have. We're going to square a, and then we're going to multiply b times a plus b, and then we're going to take our last one is b times b. Okay, I hope I didn't confuse you there in the middle there, but notice normally when we FOIL, it's a times a, and then a times negative b, so that's the negative ab right there. And then we've got positive b times a, which is positive ab right there. And then we've got b times negative b. Notice, what are these two things? They are opposites. The sum of opposites will always be 0, so these actually are going to cancel out. Therefore, your rule, your shortcut is going to be a squared minus b squared. So again, if you have a plus b times a minus b, sum of a binomial, difference of a binomial, all right, then it's going to be a, whatever a is, a squared, and then whatever b is, b squared, and it's going to be the difference of those two things. So this is your third shortcut, okay? This is the third rule here. I'm sorry I wrote over that, but a product of conjugates is the difference of two squares, the difference, subtraction of two squares. Let's do an example. Notice it has to be the exact same. This would not work if it was x minus 4 times, let's see, y plus 5, okay? That's not going to work because, hold on, let me check, xy times, nope, not going to work, all right? So it's got to be variables and the constants are the same. So x times x is x squared, and then again it's going to cancel out in the middle. So if I've got a difference and I've got a sum here, all I got to do is multiply. This is your b value, this is your b value, your a. So a squared, remember your rule, a squared minus b squared is what it's going to equal. So x times x is x squared, and then 4 times 4 is 16, the difference of those two. Let's do another one. 3x plus 7y times 3x minus 7y. Again, they're the same, all right? So this is your a value, this is your b value. Let's see, what is it going to be? It's going to be a squared, so 3x squared minus b squared. B squared is, b is 7y, so 7y squared. Can't leave it like that though, you got to simplify. So that's 3x squared, which is 9x squared. 7y squared is 49y squared. All right, again, here are all three hints, all right? These are your shortcuts right here. Make sure you have these written down because you'll be looking at these as you do your exercises. Let's look at an example. 87 times 93. Well, I can rewrite 87 times 93 as 87 is 90 minus 3, correct? That's the same as 87. And 93 is the same as 90 plus 3. But notice here, this 90 and this 90 are the same, right? Negative 3 and a positive 3. What does this look like? Well, this looks like a minus b, a plus b, because a and a are the same. They're both 90. B and B are the same. They're both 3. So how can I solve this? Look at your formula there. If it's the difference and the sum, my final answer is going to be a squared minus b squared. Well, what's a squared? A squared is 90 squared. A is 90, so that's squared, minus b, which is 3 squared. What's 90 squared? 8100. And that 3 squared is 9. So 87 times 93 is 8,091. Pretty cool. 72 squared, well, that's the same as 70 plus 2 squared. Correct? 72 is the same as 70 plus 2. Well, that's the sum, the square of a sum. So your final answer is going to look like a squared plus 2ab plus b squared. Here we go. 70 is represented as your a, 2 is represented as your b, so I've got 70 squared, a squared, plus 2 times 70 times 2, plus b squared, which is 2 squared. 70 squared is 4,900. 2 times 70 times 2, that's 4 times 70, 280 plus 4. Therefore, my final answer, what is 72 squared? 5,184, and you didn't even have to use a calculator. All right, last one. Expand a minus b cubed. Well, that's saying a minus b cubed is the same as a minus b times a minus b squared, correct? Well, sure. We're just rewriting it a different way. But notice, what can I do with this guy right here? That's the square of a difference. So that's going to look like a squared minus 2ab plus b squared, correct? So a minus b is going to be a squared minus 2ab plus b squared times a minus b. And then from there, I can just distribute. A minus b times a squared is a cubed. A times negative 2ab, that's negative 2a squared b. Just distributing it to every single term, plus ab squared. And then I've got to distribute the negative b to a squared, the negative b here, and the negative b to the last term there. Notice, do I have any like terms? Well, sure. Negative 2a squared b and negative a squared b. Positive ab squared and positive 2ab squared. Anything else? Nope, that's it. I can combine like terms, and here is my final polynomial. All right, that is it for now. I will be on page 392 in the next video to do some example problems.